Continuing on with the previous video on chapter 1.9, graphing quadratic equations, we have another one: find the x-intercepts, y-intercepts, vertex, interval notation of decreasing function, interval notation of increasing function, and a function of 3. Recall, in order to find the x-intercepts, we plug 0 for y. So this is 0 is equal to, and the other side gets remain untouched, x squared minus 6x minus 16. And then from here, this is just a review of chapter 1.6, where you have to factor out the polynomial and then solve. This is simple. Negative 16 goes on top, and then negative 6 goes at the bottom. Be sure to write down the list. 1 and negative 16, 2 and negative 8, negative or 4 and negative 4, but I can already see that 2 plus negative 8 is negative 6. 2, negative 8. So the factored version of the polynomial becomes x plus 2 and x minus 8 is equal to 0. From here, split, so that we have x plus 2 is equal to 0 and x minus 8 is equal to 0. Simple algebra, subtract 2 to both sides. X is equal to negative 2. This side, we need to add 8 to both sides, and x is equal to 8. We have now found the x-intercepts of the function. Now, in order to find a y-intercept, we plug 0 for x. And again, in order to find a y-intercept, it's usually a little bit easier than the other way around. Y equals, I'm going to keep the x blank, and plug 0 in for x. 0 times 0, which is 0, minus 6 times 0, which is still 0, 16. So the end result will be negative 16. This is considered to be the y-intercept. In order to find a vertex, we need to apply the formula negative b over 2a, and then the function of negative b over 2a. To help structure this problem out, I'm going to rewrite y equals x squared minus 6x minus 16. And this is in the format of x squared plus bx plus c, where a is 1, b is negative 6, c is negative 16. b is 6, but because of the negative sign, it's going to be negative of negative 6. So I'll just write down the intermediate step over 2a, 2 times 1, because of the 1. This simplifies out to be 6 over 2, or just 3. This is considered to be the x of the vertex. So we need to actually plug this back in order to find out the y of the vertex. Y equals, I'm going to give this space, and plug in the 3. Apply the math, 3 to the second, 6 times 3, 9 minus 18 is negative 9. Negative 9 minus 16 is negative 25. So we have both pieces of the vertex, the x of the vertex and the y of the vertex. So be sure to write down the vertex as an order pair point. Vertex is at 3, negative 25. So far we're uncovering bits of information about how the graph will look like. It's now time to graph the line. The x of the vertex is at 3, negative 25. So I'm going to put this as 3, and then 25, I'm going to put as an arbitrary value. Probably put this by every 5s. This is negative 5, negative 10, negative 15, negative 20, and negative 25. So 3, negative 25. That's the lowest point of the parabola. The x-intercepts is at negative 2 and 8. So the x-intercepts is at negative 2 and 8. At negative 2 and 8. So 3, 4, 5, 6, 7, 8. We have now enough information to plot the parabola, which will look like this. And now we can talk about the characteristics of the function. And one thing I should state as well is that we should distinguish the y-intercept to be at negative 16. The more information you have about the function on the picture, the better. So negative 16, the y-intercept, will be about here. In order to find the decreasing parts of the function, we see that the function, the parabola, the left side, is pointing downwards like this until it reaches to the lowest point of the parabola, which is here. So the decreasing function interval notation will go from negative infinity, because it will be decreasing the farther that you go to the left side, up to 3, and the increasing function will start from 3, and it will increase over time the farther on the x direction you go. So it goes from 3 up to positive infinity. The last part of the question states that we need to find a function of 3. So that's essentially plugging 3 in for the polynomial, which we have stated earlier by the question x squared minus 6x minus 16, x squared minus 6x minus 16, and then all we need to do is plug in 3 in for x. Apply the math. So 3 to the second is 9, 18, 16, and 9 minus 18 is negative 9 minus 16, which is negative 25. And you want to state your answer as a sentence. The function of 3 is equal to negative 25. So to wrap this question, we were able to find x-intercepts by plugging 0 for y, and then coming up with a list so that we could find a factored version of the polynomial, which was x plus 2, x minus 8 from this information, splitting up the work, setting it to 0, and then solving for the variable x equals negative 2, x equals negative, or x equals 8, which is considered to be the x-intercepts of the function. So just don't forget the x-intercepts means that when you graph the line, it will cross the x-axis at some points. The same will be for the y-intercepts. So vice versa, we're going to plug 0 for x. And again, in order to find the y-intercepts, it's pretty much easier than finding the x-intercepts. 0 to the second minus 6 times 0 minus 16, which is negative 16. So again, what that will look like visually is just a general information, is that where on the y-axis will it cross? Could be on the top or could be at the bottom. The vertex needs to follow this curriculum, negative b over 2a, and the function of negative b over 2a. That means you need to plug in what b is by the standard form of the polynomial, ax squared plus bx plus c, and then I'm just rewriting the question out, x squared minus 6x minus 16, and you can see that your a is 1, your b is negative 6, and your c is at negative 16. By the b value, which is negative 6, you see that substitution there. You can just do the math. Negative of negative 6 is positive 6 over 2 times 1, which is 2. 6 over 2 reduces down to 3. 3 is considered to be the x of the vertex. And recall when you're working with order pair points that it has an x comma y. So if we found the x of the vertex, we need to plug this back in, the x, which is what you see, the 3 and the 3, in order to find out what the y value is. 9 minus 18 minus 16 will give you the result of negative 25. That's why it's imperative that you need to write your vertex as 3 comma negative 25. Now with all the information, we can start talking about the characteristics of the function itself. 3 comma negative 25, you go 3 to the right and then 25 down to give you the lowest point of the parabola. And then we can see that the function is decreasing from negative infinity up to 3. So 1, 2, 3. From negative infinity up to 3. And it's increasing from 3 to infinity. The last part of the question was just plugging in a random point of the function, 3. So you see that the x value got substituted as 3, and then you just apply the math. 3 to the second is 9. 6 times 3 is 18. And then apply the math. 9 minus 18 is negative 9. Minus 16 is negative 25. And that's why you want to write down your answer as f of 3 is equal to negative 25.